Hi everyone, let's solve today's Leetcode problem, which is problem number 3043. Find the length of longest common prefix. It's a medium problem. You're given two arrays of with positive integers, array 1 and array 2. A prefix of a positive integer is an integer formed by one or more of its digits, okay, starting from its leftmost digit. For example, 123 is a prefix of integer 1245, while 243 is not. Okay, a common prefix of two integers a and b is an integer c such that c is a prefix of both a and b. For example, this and this have a common prefix 565, right? And 5655, while 1223 and 43 something something do not have a common prefix. Okay, you need to find the length of the longest common prefix between all pairs of integers x comma y such that x belongs to array of 1 and y belongs to array of 2. Okay, between all pairs. Okay, we have to find the longest common prefix. Return the length of the longest common prefix amongst all pairs. If no common prefix exists, return among them, return 0. Okay, so this is what the problem is, that we are given two array and we have to find the longest common prefix between any elements from array 1 to any elements in array 2. Okay, and the prefix, if you see in these two, so 5, if we see the prefixes, right, so 5 and 5 are matching, 6 5 6 5 6 are matching, 5 6 5 5 6 5 is matching, 5 6 5 5 5 6 5 5 is also matching, and after that with this 3 and 4 it's different. Okay, so here the maximum length was 4 if I just compare these two values, right? So maximum length there was 4. So that was about that. Now let's see the constraints. So array, both the array can be up to 10 to the power 5, 5 into 10 to the power 4 length, and these values can be up to 10 to the power 8. Okay. Now approaches that we are going to cover as part of this problem. One is the brute force and the another is optimal approach. One would be using set data structure and another one would be using trie data structure. Okay. So now, if we take this example, so here when we check for this prefix here 1, so if we check for this in this sense in array 2, there is only one element. So we will check, compare with that particular element only. So when we compare 1 and this 1000, the common prefix between them is 1, right? Now, when we compare this 10 with 1000, the common prefix between them is 10. Okay. And when we compare 100 with 1000, the common prefix between them is 100. Okay. So, among these, common prefixes between the three possible pairs in this example, the maximum length was 3 and that is for 100. Okay, so that is like this, and we have to, I mean, compare all the pairs and then return the answer. So yeah, now one more thing here, that for this comparison that we are doing between two numbers, right? So these we can do, I mean, via two way. One is using this division operation. So if we just take this pair, let's say 10 and 1000, and if we have to see the common prefix between them, right, so we can keep this one constant and then keep on dividing this value. Okay, so when we divide this, so divide this by 10, so it will be 100. Okay, now further when we divide this value by 10, it will become 10. Now when we compare these two values, those are same, right? So similar way, I mean, by division we can do such comparisons and find the common values. Okay, and another one is using the string comparison. Now let's say if I convert these values into two different strings, and if I make this prefix comparison, that I'll match the first value. Okay, it is matching, so we are good. Then the second value, it's matching, then we are good. Then third value, there is no third value in this one, right? So we have only two length, prefix length, which are common here. So this is the string comparison which we can use to do the prefix comparison. So these are the two ways to do the comparison, but in this particular problem, I'm going to just use the string comparison way. Okay. Now let's check the brute force approach for this. So as problem itself suggests that we have to consider all possible pairs and take the maximum length. Okay, so we have to check prefixes of all these pairs. So now if we start with this one, for this particular index, Okay, so basically when we form two pairs, right? So how we do it using two loops, right? That first loop will iterate on the first array, another loop will iterate on the second array, right? So same way we will do, there will be two loop that will be going through. So here let's say it's I, it's J. Now, as I said right above that we will do the string comparison. So now we know these are our two pairs. When I write this as in terms of strings, so this is how they will look like. Now I will do the start my comparison. So these two values are same, and after that there is no value here, right? So the max length that it will give me 1. Okay, my answer is 0 and I'll update it to 1. Now after this I'll move my I ahead, so it will go to 10. Now again I'll do this comparison of 10 with this 1000. So in this the length will be 2. So I'll update my answer to 2. Then I'll move my I further for 100. Now I'll compare this 100 with again 1000. The common between them is 100, as you can clearly see, and this is the string comparison that we will do. So here length is 3, so it is greater than 3. I mean our answer 3 is greater, so we'll update. So then we update it. So after comparing for this j, we explored all possible i's. Okay, now what we could do, we can move our j, and for that another j we can move all our i's like that, or for one particular I we can keep on moving j like that also we can do. Okay, so that is how we will explore all the pairs, and then we will do the string comparison. So and then we will keep on updating our answer. So this is the straight brute force approach that we are going to follow. Now let's check the code for this. So this n and m is the sizes of this array 1 and 2, and then we have taken this answer to calculate the max length. Then we are going over the first, iterating over the first array, and then iterating over the second array. Basically we are having these two values pair. Okay, now we are doing this string conversion. A will hold the value of array 1 of I, and B will hold the value of array 2 of I. Now this is our x pointer, which is nothing, we will use that for string comparison. Okay, so this x basically need to be less than a of a dot size also, because in our example it was 10 and 1000. Okay, so we need to, when we are moving, basically this is nothing but a pointer right here. So when we are moving this pointer here x, so this need to be within the length, right? So that is what we are comparing for both of these x, this pointer need to be within the length. So x should be less than a dot size, this one, and x should be less than b dot size, this one. Okay, if it is, then we will do our comparison. So if these values are equal, we will keep, we are all good. Okay, now let's say instead of 0 here, if it would have been 2 like this, so we couldn't do anything, right? Only till here only we had matching or common prefix. After this values are different, this is 2, this is 0. So for that reason we will break. If array of a of x is not equal to b of x, then we will break. If not, then we will keep on moving our x pointer that we have. Okay, so at the end till whenever it break, right, so our x was pointing 1 before that only, so we can take the max of answer comma x, and that is how we will be able to take the maximum. Okay, we are doing the string comparison over here, and at the end we can return the answer. So now if we see the time complexity for this one, so first loop is going for O of n times, and another loop is going for O of m times. Now this is the string comparison that we are doing, and in the problem it is said that string the value this digits, right? This string is nothing but a digit, right? And each of the values in this array can be up to 10 to the power 8, right? So again, I have told this in many of my videos, but again, so number of digits in this value would be log of x base 10 plus 1, right? So now if I place this 10 to the power 8 in place of x, so it would be nothing but 9. Okay, so this means that it will be of length 9, and it is clearly evidently, I mean, visible, right? So length 9. So this loop will run for of 9 times. Okay, so now if we and this m and n can be up to 10 to the power 4 or 4 5 into 10 to the power 4 each, right? So altogether it will be o of, I would say, 9 into m into n like that. Okay, which will basically, if you see, n can be 10 to the power 4 into 5 into 10 to the power 4 into 9. Altogether this will be 10 to the power you know greater than basically 10 to the power 9. So this will basically give us TLE, okay. And space complexity, if we see, we have not taken any additional space, just the strings that we are taking, and that will be also O of, I mean, max can be O of 9 only, which is eventually like constant. So space complexity is of 1. This approach will give us TLE, so we have to think in optimizing this, okay. So since you see that we are generating all the, I mean, we are generating all the pairs and then comparing between them, right? So instead, what if instead of considering all the pairs, if we generate all the prefixes of one array and check for all the prefixes from the second array into the first array, if that exists or not. So that is what we are going to do. So we will do what? We'll put all the prefixes of array 1 into set and check for all the prefixes of array 2 into set if it exists or not. Okay. So first step is putting all the prefixes of this array into set. So for 1, it is 1. For this 10, the prefix is like 1 and then 10. So since 1 already exists, so it is a set, so we won't write it again. Now for this one, first prefix is 1, so 1 already exists. Then it is 10, so 10 also already exists, then it is 100. Okay, so we write it 100. So basically putting all the prefixes, we are putting all prefixes, though here like prefixes didn't look like that. Now let's say uh, here let's say one, there would be one more thing, maybe 45 for example. Okay, so for this, if we put 45 also, so it will look like 4 and then 45, because that is how all prefixes of 45 would look like, right? So yeah, and then what we will do, so this is first step is done. We have added all our prefix into the set data structure. Now for all the prefixes of this value, we will check if this exists in set or not. If it exists, then we will keep on taking the max. Okay, so if we take the first prefix, so this is 1. 1 exists here. Yes, it exists. So what was the length? Length was 1. So we'll update the length. Okay. And then if we check for the next prefix 10, yes, 10 also exists. So we will update 10 is of length 2, right? So we'll update our answer. Then we will see for 100. 100 also exists. So we'll update our answer to 3. Now we'll check for 1000. Now when we checked for 1000, it doesn't exist here in this set, if you see, which means that we cannot find further any prefixes which will exist in the set, so we can break from there. Okay, and this is the max answer that we find. So first step was inserting into the prefix set data structure all the prefixes and then checking for all prefixes of array 2. Okay, of array 2. So that is how we are going to do. Now let's check the code for this. So we have taken this unordered set of string, and as I told that I'll be doing string comparison over here. So answer that will be 0 initially. Now we are iterating on the first array, and this s is nothing but string value, this num, and here basically we are taking all the prefixes of these length, okay, of length 1 till s dot size, and we are inserting that into our set. So this s dot sub str is nothing but a c++ stl to get the substring starting with this value and of length this. Okay, so starting with 0 of length I. Okay, and I here it starts from 1 till s dot size, right? So that is how we'll be getting the this sub str, and then we are inserting this value into the set, basically generating all the prefixes for array 1. Okay, so this is our first step. Now after this, we are iterating on the array 2, and then this s holds this again the value num, and here we are checking for all the prefixes of this num in array 2, that if it exists in the set or not. So st.count this sub str 0 of length I, basically checking all the prefixes if it exists in this set or not. Okay, if it exists, then we can take the max. Okay, so max of this answer comma I, that will be our answer. And here we can also add one more block saying else break. Okay, if the string that we are, let's say, checking 1 2 3 4 5, right? Now for one itself, let's say I find one, in above example we found one, right? Now 1 2 we didn't find, right, in the set. So when we didn't find 1 2, there is no further, reason to go ahead, because if 1 2 itself is not there, which means 1 2 3 cannot be there at all, because we are considering the prefixes, right? So for that reason we can directly break here. So this else block also we can add. Then after that, we would have considered all the prefixes and check that into the set, okay, if it exists or not. If it exists, then we can take the max of that length, okay. So this was the step 2 that we did. So yeah, and at the end, this our answer will hold the maximum, longest common prefix. So now if we check the time complexity, so this first loop is going for length n, okay, and this one is going for of m times, and each of these here inside, this is working for, you know uh, basically O of digits time, if I say. So this iteration is for number of digits. So let's say number of digits can be max up to D, if I say. So this will go for D. And there is one more thing, if you see. So we are inserting this into the set, which will be of one operation, but we are doing this s dot sub str operation, right? So s dot sub str can take up to, O of n time, n where n is a string, but here n is nothing but the number of digits. So it can be d of square, right? Okay, because due to this s dot sub str. Okay, so if I write it, so it is nothing but O of, but this sub str, it, since n itself is, here digit itself is 9 only, which is very small. So sub str calculation itself is, constant, we would say. So we can write it as d only. Okay, so it is O of n into d plus this another loop that is going for m, and again same thing. We are going over all the digits, and here also this sub str calculation is there, but since the length itself is very less, so it would be constant. So m into d. Now if we take consider the space complexity, so we have taken this set data structure, so that will hold all the prefixes. And what will be the prefixes here? So it will be number of digits, that I would say, into of digits into, so we are inserting the values from this first set, right? So it will be n. Okay, so yeah, and number of digits is nothing but log of this max value. Okay, the calculation that we did above. So this is about this, and with this approach, our problem will pass, and we can also solve this same problem using trie data structure. Time complexity, yeah, so this is the time complexity for this. Now let's check the trie solution. So in try also we will do the same as we did above, but instead of using set, we will use try here. So there we were inserting all the prefixes into set, right, set data structure, right? So here instead of doing that, we will insert all the prefixes into try data structure. So I'm hoping that kind of basics of try. If not, then yeah, I mean, I can explain this, and it's a good problem to understand the try data structure as well. So now this from the first array we will insert all the prefixes into trie, and from the second array we will check if the trie contains this or not, same as above. Now to insert this value, we know that trie basically holds references, right? So it will be, let's say, some values, then this will hold reference to this, again same values, like that, right? So now what all values it can hold, if you think, right? So these values are basically prefixes, right? I mean, a number can be from 0 to 9 only, right? A digit, I would say. A digit can be from 0 to 9 only. And prefixes also, if I write, so it will, I mean, numbers into that digit will be from 0 to 9 only, which means our try a particular node can hold, you know, can be of length 10. Okay, so our prefix can be of length 10, and like this 1 2 3 up to 9. Okay, so this is how our each node will look like, and initially it will be all pointing to null. Okay, null null null, like that. Okay, now this is our root node, I would say. Now what I would do, I will insert over here. So when I took this first one, right, so I will So one, if I have to insert, so this is what one is. Now what I can do for this one, I can create one more node, same as this node. This is one node, right? So same as this node, it will have null 0 1 null like this, and then till again I mean, this null is nothing but the value that is this array is holding. Okay, so this one we have created this reference, another reference, okay, that this prefix exists of one. Now for one, if we see again, so this one, it has its children. I mean, this is no longer null. Okay, this is no longer null. It holds a reference. So here when we came, so since this one holds the reference, so we can mark this one into this. Now another prefix that we have to update into our trie was 10, right? So now to update 10, we can go one by one. So we went to one first. One, for one we saw that it existed, so we will go to its child. Now for 0, if we see, so 0, there is no further child, or no further reference. So we will create a reference for this, okay, same as above. So this will no longer point to null, it will point to this reference. Now we will update our trie for these values also. So first we will update for 1, so 1 is already updated. Now we will update for 10, so you see 10 is already updated. Now we will update for 100. So for 1 we saw that next pointer that is pointing to this one, then 0 where it is pointing here. Now 0 is holding also a reference. Now so this is 1 0, and there would be another 0 because we are doing for 100, right? So for another 0, there initially it was pointing to null. Now we will make it point to another reference. Okay, new node that we will create. So this is how it is. Now we have basically added all of these prefixes into this set. Okay, now I mean, this is looking straightforward because I mean, it is holding this 110 and like that. Now if we have, let's say, 45 also, so what we would have done, so here somewhere it will be 4, right? So that is also pointing to null. Now instead of that, we will point that to, we'll create another node and we'll point it here. So for 4 it is done. Now next is 4 5, right? So 4 it is here. Now for now we have to check the next value since it is holding the address of its next value. So we'll go to here, and here also if you see 1 2 and somewhere 5 and then 9. Okay, 5 is initially holding the value null. So now we will create one more reference. Okay, one more node basically storing in this reference 5, like this. So initially it will be all null. Okay, so that is how we will be able to add 4 5 also. Okay, so we will update all the values from array 1 into our trie. That is how we did here. Now after that we will iterate over this array 2 elements one by one, and we will check for all their prefixes if they exist here or not. Okay, now we'll start here. So we'll check for 1. Okay, we check 1, so it references not null, which means this exists, so we are good with this. Okay, now we checked for 0. So so far length was 1, right? I would say maximum length was 1. Now we check for 1 0. So 0 is also holding some reference, which means this prefix exists. So this is 10 is also true. Now we'll check for 100. So 100 also, it is holding some reference. Okay, it's not null, so which is also true. So length is now 3. Now we'll check for 1000. So 1 0, we check 0, and then for 1000. Okay, this is pointing to null, which means that there is no further reference to this value, which means that this prefix 1000 doesn't exist. So we can directly break from there. Okay, and what was the length that we got so far? That is 3, and that would be the maximum length. Okay, that we got. So that is the comparison, that is how we are going to do. So first was creating this node. So normal standard template for creating a trie node, and then each node, this is basically one node of the trie, this is one node of the trie, right? And altogether this is nothing but a trie data structure which holds this initial root node, and then it keeps on building. Okay, and how it keeps on building, basically we are inserting all these prefixes, right? So it is storing the next node reference in the current value. Okay, and it will keep on extending like that. So that is how we insert, and while searching we need to keep one pointer. which will go over these, okay, and check if these values exist or not. So that is what it is. Now let's check the code for this. So as I explained, so this is a trie node which will be of length 10 because values can be from 0 to 9. Then we are initializing this trie node, the child that we have created. Basically, each node will hold nothing but the array, right, of length 10. So we are initializing each of this child with initial value as null, that there is no further reference to it. This is just a node that we have created. Okay, so this is about the trie node class. Now then we have a trie class where initially this trie that we had, right, it will have a root node, right? So we have created this root, which is nothing but a trie node. Now we have initialized this here new trie node in this constructor. Now so this is we how we will do. Now I'll explain two methods over here, but now we'll start. Let's start from the our main method. Okay, so how it is. So this is our method to calculate the longest common prefix. We have initialized our trie data structure here like this. Now we are iterating on the first array and then inserting this value num. Okay, and this will handle to insert, I mean, all the prefixes of it. Okay, so that is a one benefit of trie data structure over here. I'll explain more into it. So this num that we have, basically all the numbers one, it will insert into trie, and trie will insert all the prefixes, it will handle it. Okay, so this is the first thing that we did. Now this is answer that we are holding, and which will be returning at the end the max answer. Now this was the first, and the second step is that we have to calculate the maximum length, right? So first was we inserted all the elements from the first array, and then we are iterating over the second array, and we are checking the if the trie in this trie find the longest prefix for this num. Okay, so this is the num from array 2 that we are passing, and this will give us some length, and then we will take the max among them and return the answer. Okay, so that is I mean, if you see, this is similar as above, right? So we were generating all the prefixes from array 1, and then we were finding for all the prefixes from array 2 if it exists in array 1 or not. Okay, instead of using set, we have used here trie. Okay, and yeah, so now let's check these two methods. So insert, as I mentioned that we need to iterate over this trie, right? So we have this trie data structure, we need to iterate. So for that we have this node uh, node as a trie node. I mean, the pointer to iterate. So that is now starting with the root. That is initialized with the value root. Now we have this num, and we have stored that into num str value variable. Now we are iterating over each of it characters of this num str. We are calling it as digit, and we are getting the value of it. Okay, so that will basically be the index. So each of this node was nothing but an array, right, starting from this index to 0 to 9, right? So we will this digit we will get from this num str, and will when we do the subtraction from 0, it will give us the index. Okay, so now we got the index. After that we need to check if it child exists or not. Okay, if its child doesn't exist, okay, so what we need to do, in its child we need to put a new node. Okay, like we did, right, when we were inserting when we had to insert a prefix for value, let's say 100 we have to insert, right? So for one we can go here, um, I would say, like, we are iterating on this string one by one, right? Character by character. So for this one, we first check that if it holds any value or not. So if you see that node child would be null, right? It is null. So there we need to put one other node, okay, like that. So if we don't have this child node, then in that case, for the child reference here, we will, insert a new node. So for here, we inserted a new node, this one, if it is already existing. Okay, now let's say when we were calculating for, we put this value 10 into here, right? Now when we were checking for 100, we checked for 10 if it already existed or not. So for 10 it already existed, right? Now while for putting 100 we know that 0 doesn't exist. So if it already exists, then we need to move our pointer from here to here. Okay, so that is how we will move. Node will be next to node child of index. Okay, so that is how we will do, and that is how we will be able to insert all the values here. Okay, so here if you see, we didn't really needed to go over all the generate all the prefixes and then do. So if the number was, let's say, 1 2 3 4, it's not like in above what we were doing, we will getting this prefix 1 then inserting 1 2 and then inserting 1 2 3 and then inserting 1 2 3 4 and then inserting, and we were getting these values every time, right, using this s dot sub str above, right? So that was the additional kind of time that we took above, but here that is not the case. Here we are just iterating over this and we are keep on inserting the next values. Okay, so as simple as that, it is just saving us some values, some operation of s dot sub str calculation. Okay, so this is about the insertion. Now let's find the longest prefix. So again same thing, we need this node to iterate over the root, then num sub str will hold this num, and this is the length that we are going to have across. Then we are iterating over this digits of this num str and getting the digit, the index of that particular digit. Okay, this is the node and this will hold some value. We need to know the index. Okay, because using this index only we can know if this child, whatever node that we had, if this has this node that we have, right? So this particular child at this index holds some value or not. Okay, so if it is holding some value, which means we can go to next of this child. Okay, we can go to this child and we can also increase the length because it exists, which means this is one common prefix. Okay, so we can increase. If it doesn't exist, then we can break. Okay, so yeah, and at the end we can return the length. So this is how we will be able to find the longest prefix. So now if you also see, so when we were finding, so here let's say 0 1 like this and 9. So for 9, when there was a reference, okay, so what we did we went ahead here. I mean 0 to 9. Basically whatever reference this one holded, holded the reference of this node, right? So we came to this node. Now here we will check again. Let's say for this we need to check for this 0. After 1 we need to check for 0. Okay, so now let's say this also holded some reference. So we can go to this node and then further keep on checking. Okay, so each of this node value is holding reference to another node. Okay, so that is how we are doing. So now if we see the time complexity, so this is O of n, the first loop. The second loop is taking O of m time, and each of this is nothing, this operation insert and find longest prefix is nothing but going over all the digits of this num str, which will be which can be max up to 9 only, right? So this is O of, I would write it as n into digits plus m into digit. Okay, so that can be the max. And space complexity if we see, so we are using this trie for inserting all the values. So we are inserting this all the prefixes of this array 1 into trie, so which can be of n into digits. Okay, so yeah, that's about the space and time complexity for this approach. If you see, the first and the second approach are almost similar. Only difference was that in first set approach we were using that s dot sub str only. So here there it would be a d square, but since the digits itself was quite small, so we considered that as constant. So space and time complexity is same here. So this problem was more about understanding the trie, and to this try here is a little bit beneficial. Basically it's saving on that all the prefix calculation or using that s dot sub str. But when the string length is further more longer, this try becomes more beneficial, or we have to do some frequent prefix queries, or we have to calculate if it ends with or start with some that sort of thing. So that at that point prefix become more beneficial. It saves some more time and space like that. Okay, so that's about this, and I hope you understood this approach that I explained. Thank you for watching. Stay tuned for next videos.